Hi everyone! Today we're making ice cream, but we're also diving into real science. How does a bag of salty ice freeze our ice cream mixture? We're talking freezing point depression, phase change, and how salt changes the way water freezes. Let's make ice cream and learn some thermodynamics. Firstly, you'll need 1 cup of half and half or a cream and milk mixture, 2 tablespoons of sugar, half a teaspoon of vanilla extract, ice, 1/3 cup of salt, preferably rock salt, but as you can see, I use just regular salt. 1 quart size Ziploc bag, 1 gallon size Ziploc bag, and either a towel or gloves to protect your hands from the cold. This experiment works because of how salt affects the freezing point of water. Let's mix our ice cream mixture and break it down. First, we're going to combine our half and half sugar and vanilla in the small Ziploc bag. Seal it tightly and make sure that there's minimal air inside. Inside this bag, we have a liquid mixture. To turn it into a solid ice cream, specifically, we need to remove heat energy so that the molecules can slow down and lock into a solid structure. That's where the salt and ice come in. Now, in the big bag, add ice and about a third cup of salt. Here's the key. Salt lowers the freezing point of water. Normally, water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. But when we add salt, it can go much lower, sometimes as low as minus 10 degrees or lower. This is why you need gloves to protect your hand, or a towel works too. The salt dissolves into sodium and chloride ions. These interfere with water molecules trying to bond and freeze. As a result, the ice needs to absorb more heat from its surroundings, including from our ice cream mixture, to melt. That's called freezing point depression. Now, place the ice cream mixture into the salty ice bag, seal it up, and shake. For my mixture, it took me about 10 minutes for it to start forming into ice cream, but that depends on your surrounding temperature. As the salty ice melts, it pulls heat from the ice cream mixture. This is an example of endothermic melting. The system absorbs heat, which lowers the temperature of the cream. The molecules in the cream slow down and undergo a phase change from liquid to solid. This is a physical change, not a chemical one. We're not changing the molecules, just how they're arranged. The same way that you've probably studied in particle physics or the particle properties of matter in your science books. After about a good 10 minutes of shaking, which was obviously tiresome, as you can see, the liquid cream has turned into a soft, frozen solid ice cream. Let's review the science that we use in this experiment. Firstly, salt lowers the freezing point of ice water. Next, melting ice absorbs heat, which cools the cream. The cream mixture loses energy and undergoes a phase change to a solid. It's all about heat transfer and molecular motion. And yes, it's delicious. So next time you eat ice cream, remember, it's a frozen dessert built on real physics and chemistry. We used freezing point depression to go below 0 degrees Celsius without a freezer. We used phase changes to freeze our liquid. And we saw how heat transfer makes it all happen. Thank you so much for watching this video. See you guys next time.